Hey everybody, welcome to The Secret History Living in Your Aquarium. This is the channel where we cover deep dives into subjects all over the aquarium hobby. And we go to the peer-reviewed researchers and sources whenever possible. When academic sources fall short, we go to the experienced experts in the hobby, meaning I try to combine both experience, evidence, and data-backed science rather than parroting whatever is cut and pasted on the top 10 search results of Google. So today your video is going to be about CATAPPA almond leaves and if they're a ripoff, if they're really worth it, what they're all about, their chemistry, and so much more. Today's video is also sponsored by, well, you. So thank you so much. You, the viewers, as usual, I want to thank for leaving questions and comments, leaving information related to the video and today's topic. And I want to give a special thanks to the channel members and super chatters who, for $1.99, really support my budget for research and the time that I put into these videos. This one took dozens of hours, and I accessed 3 or 4 scholarly journals that required paywalls to get through. So they can get a bit pricey, to say the least. And as often is the case with deep dives, this will be an episode that you can listen to just like a podcast. Until I can afford to get some infographics or animation going on the screen, we'll just be looking at footage of my home fish tanks rather than anything related to CATAPPA almond leaves or Indian almond leaves at this time. So thank you guys so much, and I hope you guys enjoy today's video. Hey guys, so in this video we are examining Indian almond leaf trees, also known as Termalina CATAPPA trees, and we will be going in depth discussing their leaves, their uses, their chemistry, ecology, and ending by covering some common questions about the most effective way to use these leaves and their tannins as a whole in Blackwater aquaria and just normal aquaria. You don't need to have black water to get the benefits of these leaves, and we'll go over that towards the end. So what are Indian almond leaves and what are they used for in the aquarium hobby? And honestly, what makes them such a special and coveted addition to your fish or shrimp tank? Let's get the elephant out of the room. CATAPPA leaves, or aka Indian almond leaves, are they just an overpriced ripoff? Like, what makes them special? Why not just use your local maple leaf or something instead? They have just as many tannins, and they're full of other compounds that are useful as well. So to quickly answer this question and kind of the thumbnail before we dive in, the answer is yes and no. They kind of are a ripoff in the sense that many leaves have tannins. Almost all leaves have tannins, and we know of over 8,000 unique tannins in various plants, from CATAPPA leaves to maple leaves and everything in between. Now, CATAPPA leaves have several chemicals that are of interest, including not just tannins but flavonoids. So they also contain campherol and quercetin. And then the tannins that they contain that are of special note are punacalin and punacalogen, as well as terracatin. And they also contain a chemical group known as saponins and as phytosterols. So due to this chemical richness, the leaves and the bark are used for a whole lot of purposes throughout human history and throughout the globe. They fill in as a nice substitute for leaves that are native to most of the tropical world and other ecosystems, even though they don't fit the profile specifically of the leaves that may be where your fish are specifically from. But they do have a lot of the beneficial traits and effects that we would hope for in a plant. So in that sense, they're a great general botanical to add to your aquarium. They've also shown to be active fighters of Plasmodium falciparum, which is basically malaria. So it means that these leaves are similar to quinine in that they have this unique property that can actually fight malaria, and specifically it can fight drug-resistant and quinine-resistant malaria, as well as several other nasty bacterial strains like strep and staph, and they can fight fungal infections. So pretty interesting, and that's something you can't just get in any leaf. So in that sense, they are special. Now, are we usually using them to fight those specific things in our aquarium? Probably not. So the true reason that CATAPPA leaves are so popular in the hobby is because they're extremely abundant and extremely cheap. But they're also really sturdy. They're almost like a leathery texture, especially when dried out, and they last in the aquatic environment a long time. So when you put them in the aquarium, they may last you anywhere from 2 or 3 months to 6 months before they have broken down. But more to the point, they grow natively in over half of the tropical jungles of the world and nearly every place that fish are farmed in the world. So it's out of sheer coincidence that these leaves fell into the ponds of many fish breeders and fish farmers around the equatorial regions of the world where the tree grows, and they started to use them as kind of a backup source or a stand-in source for the leaves that would have been native to wherever the fish they are breeding are from. So that being said, each botanical element that we add to our aquarium is unique, and if nothing else, Indian almond leaves are a good general choice because there's a ton of research on them, and they've had a lot of science going into studying the safety of them, the properties within them, the chemistry of them, and the Indian almond leaf is oftentimes free of pesticides as well as fertilizers and harmful chemicals because they grow over 130 feet tall in oftentimes developing parts of the world. They're actually just a decorative tree. They're not used for a whole lot more other than in Polynesia. They're used as the wood that's of choice for canoes because it's pretty water resistant. But other than that, it's not the ideal wood compared to most of what grows in the areas it's native to. And the food that it produces, the nuts and fruit on the tree, which are not related to the almond you'd probably think of in a candy bar or something like that here in the Western world. It's not at all related to that tree. It's only mildly useful as a food. So there's these big trees that are all over that are deciduous, and they lose their leaves in the dry season. So you've got all these leaves, tens of thousands, if not hundreds of thousands of them, that fall at the foot of the tree, and the people had to figure out what can they do with them, and sell them to Americans for $1 a piece seemed like a good idea. So in one sense, yes, the price is kind of ridiculous, but if you buy them in bulk or if you buy them in packs, they're not bad. And if you just consider that you only need a couple for whatever your uses might be, it's not that high of a price to pay for the benefits that it brings, which we're going to talk about now. So these leaves have been used for well over 40 years in fish keeping and documented a whole lot. And there's some inherent properties and benefits of those tannins mentioned above that go into making this tree and this species the center of our attention. So first off, I have to mention that I have a very, very deep dive into the subject of tannins and Blackwater aquariums, if that's what you wanted to know holistically, how to set one up and so forth. So if you want a really detailed explanation of the chemistry and the various categories of tannins, as well as the evolutionary history and the human history and ecology of tannins, you can check out that, which is also an audio-based episode that came out last week and will be pinned in the comments below, or you can just go to the channel and look for the video called Tannins. So the CATAPPA leaf is from a seasonal deciduous tree. The species is found throughout Asia, and it is not at all related to the European almond tree, as I said, but it does share a name because the seed pods and the fruiting body kind of look like the almond tree from the Middle East that we're used to associating with baking and eating in trail mix or whatnot here in the Western world. So the specific species of tree we use in the aquarium hobby is from the leaves of the Terminalia CATAPPA tree. And while these trees produce a marginal amount of bitter and spongy fruits surrounded by a pit, the seeds of the tree are not really that good, but they can be dry roasted or baked and end up giving you kind of this woody textured nut that's edible. But because of this, they're not used for a whole lot other than shade in many parts of the world. Now, they're also referred to as Indian almond trees, Malabar almonds, Asian almonds, or even just the Indian almond tree, as we call it. So the leaves are specifically what we want to talk about today, and they are kind of interesting in that this tree is found over a lot of the tropical freshwater bodies that we get our fish from in the hobby. So they're found all over tropical and Central Asia, down through Southeast Asia, all of the Indian subcontinent, even up into Pakistan and slightly into the Middle East. They're found in Madagascar, the Seychelles Islands, the Andaman Islands, and all throughout the Indian islands in the Indian Sea, all the way down and across to Australia, and then up through the Pacific and the tropical areas and islands of the Pacific, all the way up to Taiwan and mainland China. So the tree grows to a menacing 35 meters tall, 115 to 130 feet tall is pretty usual. And they are a big source of wood, bark, and leaves, whether it's useful or not. Like I said, the fruits are corky and light. Naturally, they are kind of designed to float down river, and then the seeds get to their destination and new trees grow that way. So they are commonly found along sources of water. And so there is a long history of these trees also being alongside the aquatic ecosystem. So there are many fish from Asia that grow up in a habitat just rich with these leaves. Every year there's just layers and layers of them falling into the creeks and creating the mulm and the creek beds for them and all the other little organisms. So at the top of the tree, it spreads out. It's kind of a vase shape, and it sheds that enormous size amount of leaves in these tiers. So each branch as it goes up gets a little bit farther out, and they are distinctively arranged in those tiers in that vase shape, and that helps them to disperse their leaves annually into these big circular zones. And with a little help of the wind and animals eating the fruits and nuts, they're able to spread their seeds pretty effectively. And as you see them on many islands in the Pacific and the Indian Ocean, they're able to float even in salt water, then wash up on sea and grow in some cases. So they're pretty good at colonizing also, which is kind of cool. So they're used in a whole lot of folk medicine and in small amounts as food. But until recently, they were just essentially viewed as an ornamental tree placed in gardens or parks or temples, and a source of shade on hot days. But more recently, scientists have begun to examine studying the complex chemistry going on in these trees, based on both ancient and contemporary reports of medicinal properties within certain parts of the CATAPPA tree. The leaves being one of them in particular that is discussed in great detail, being made into teas, poultices, tinctures, and extracts. And so the concentrated extracts and isolated chemicals that are unique to these leaves in this tree, and the high tannin concentration within these leaves, is why scientists are wanting to study them. So through the studies, they've learned a whole lot recently in the last 50 years about these trees and about tannins in general. But when combined in specific ratios, they're finding that some of the chemicals that they've overlooked in the past may be useful medically, and it's just that they tested them one at a time, and that you need one or two of them at the same time for them to be effective. So things like properties that like anti-inflammatory or vasodilation, things like that, that have been found in some of the compounds within the plant, don't occur unless that plant is in its natural form, hasn't been boiled, hasn't been made into an extract, but rather those chemicals and compounds are left whole and intact in the plant. Because whenever you heat or cook or synthesize, obviously, of course when you synthesize, or bring down something to an extract, you're going to change the nature of the chemistry. So let's take a look at the fish, and let's keep talking about the CATAPPA tree and the folk medicine and traditional uses of this, and some of the legendary reasons why it's been used around the world. So all this research and these benefits is based on the fact that nearly every culture that has come into contact with CATAPPA leaves or the CATAPPA almond tree seem to have some folk medicine tradition or old story about using the plant medicinally for a whole range of things. So from ancient Indian texts mentioning how warring Indian cultures would use these leaves to clean and dress their wounds, which would prevent infection, to the Chinese who used the tree bark as an anti-inflammatory for people with autoimmune issues, to the Sri Lankan monks who prepared a tea made from the dried leaves, which was said to treat liver and kidney troubles, as well as to detoxify venom and other poisons. So this has sparked a lot of curiosity in the last 40 or 50 years from chemical companies and pharmaceutical companies. So although many cultures seem to use parts of the CATAPPA tree medicinally, scientists seem unsure of the actual medicinal benefits when consumed in the natural occurring ratios and conditions. Every tree can be different chemically, and this is important to remember for your aquarium. So if it's a drought for several years beforehand, but the nutrients are really high, you may pack a whole bunch of really dense, phenols into those leaves. Or if it's been cloudy and there's been a lot of rain, or it's in the underbrush of a jungle or something like that where there's a taller canopy, you may have different amounts of different chemicals in each leaf. So you never know just exactly what amount of which of the naturally occurring chemicals will be in what concentration in the plant. However, the medicinal uses and health impacts of these chemicals is no longer in doubt. The studies have made it clear that there are medicinal benefits to the components and compounds within these leaves. So when the tannins and phenols are concentrated or purified, it is agreed to be a rich source of antioxidant properties. They have been shown to also capture heavy metals and to stop or surround and then neutralize various toxins within mammals and humans, as well as in fish, reptiles, and birds. Along with this, the CATAPPA leaves themselves have been found to hold anti-mutagenic chemicals, which are those that occur in cells while DNA is being transcribed. So it is your backup system for when DNA is copying, new cells being born and dividing. It makes sure that any errors that get made get fixed, essentially. There's a redundancy in DNA, the way it replicates, and the chemicals within this plant actually help that, and they reduce the chance of chromosomal and DNA related mutations, which is really interesting and has a lot of implications for cancer as well as hereditary issues, such as maybe even inbred populations of fish. So, unfortunately, many people have cited this pseudoscientific research alongside the scientific research and kind of tangled it up into a mess of more audacious and extreme health claims that are not true. And some of the practices that people have stated that they use these leaves for are also exaggerated with a grain of truth, but they're just not scientifically backed up by anything. And that can be harmful when people follow the example led by someone giving testimonial or evidence and attributing whatever it is that they saw to the leaf. I mean, it could prevent people from getting actual effective treatments, or in some cases it could end up causing, you know, a high amount of the leaves being used in hopes of doing some sort of treatment, and then all of a sudden the side effect that we'll talk about soon of the pH decreasing and the acidity rising could have a very dire impact on certain fish. So it's important to note that just because the plant may kill cancer cells in, say, a petri dish, it does not mean that eating or drinking or swimming in the natural juices, tannins, chemical compounds of this plant are going to cure cancer. Doesn't mean that they're going to systemically or even locally cure cancer. That's just one cell, and that's all that can be said in that study. However, we do see people all over the internet and all over different products that contain either tannins or teas or tinctures that may have CATAPPA leaves or CATAPPA fruits in them, making claims about them being anti-aging, anti-cancer, or even cancer cures. And that's where the FDA has put out warnings to say, just hold your horses, you know, there's some truth to this, and maybe it is even beneficial, but that hasn't been sorted out yet, so nobody can speak to that until the science has been performed properly. So many classes of tannins have antioxidant properties, which have been found to lower total cholesterol, lower blood pressure, and also to stimulate the immune system as well as help the immune system. Other than fish's longevity and their health, tannins and certain compounds found in the leaves can also just simply improve the beauty and color of your fish. So your fish relies on all sorts of chemicals, enzymes, proteins, and compounds found in its habitat in the wild to create the beautiful colors that they exhibit and the beautiful textures and the iridophores, which cause that sparkly kind of iridescent shimmer or gasoline-like swirl on a lot of fish. That is caused by guanine and guarine crystals, for instance, whereas each color parent in a fish is created by specific elements also found in a lot of botanicals, including those found in CATAPPA leaves. So, along with sunlight and a healthy diet and stress-free conditions or lowered stress conditions, you can really get the colors to show in a fish by exposing them to the tannins and other chemicals found in not just CATAPPA leaves, but jackfruit, guava, maple leaves, alder cones, all sorts of things that are out there. But let's focus on the compounds in the CATAPPA leaf and continue on. So these compounds specifically include color-enhancing properties that have proven to impact fish in several ways. There is research proving that CATAPPA leaves are anti-inflammatory in fish, on wounds, and also on autoimmune reactions to either injuries or illness. And they're also shown to help the slime coat, or the autoimmune response that fish have externally all over their body, that is essentially their external immune system. Just like we have mucus or snot in our nose that helps us get rid of things, and also is probably a place for probiotics to congregate and be dealt with before we have to actually ingest whatever those pathogens are all the way. Fish have a similar system on their outside. It also makes them swim through the water more effectively and give chemical signals to the other fish in the water, including things like letting other fish know when they want to reproduce. So tannins in the CATAPPA leaf have also shown that they increase the amount of fish being born to an individual female fish, and they increase the survival rate of fish once they have been born. And this is true in a whole swath of different fish, but they find that the habitat that is created by the CATAPPA leaves in the water, as well as the ecosystem that they provide on a microscopic level, allows the fish to survive at much higher rates than if they're not used, even in a planted tank that has plants already. So it's an important part of an ecosystem, and these fish evolved alongside it. So these leaves have also been shown to sequester heavy metals and toxins in a way that renders them far less dangerous to our fish. And this is especially important with our shrimp, where copper can be absolutely deadly and destructive to our shrimp, even in small amounts. Well, because of the nature of tannins, which we're going to talk about soon, the way they are chemically structured, they are basically long chains of the same compound that are easily bonded with metals and stray elements, and they essentially wrap them up in a long polymer, and almost like a latex or rubber-like system, they will then polymerize it and bond with it, and that makes it so it cannot harm the shrimp or fish as much, especially if it is changed out with the filter or with water changes rather than consumed by the fish. So if the fish was eating the entire leaf, then it's not really going to help, because it's only rendered it a little less harmful. Whereas if it's floating in the water as tannins, as that yellow color, it is actually taking those compounds and wrapping each one. And just like the way SAFE or API, stress coat, or Seachem Prime would work, that is how these tannins work in enveloping the heavy metals and also other toxins and poisons, sometimes in a way which makes them such a big glob of a molecule or chain of molecules that they are no longer able to be processed by the liver or kidney of a lot of these creatures, which means that it's rendered harmless and just floats around the water and can be eliminated from the ecosystem entirely with water changes, which is really amazing. So it's also been seen that these tannins prevent and or even cure or kill cancer in certain cells. Now, the extent to which this is occurring is not exactly clear, but there's a whole lot of money and research going into it. And needless to say, there's something going on medicinally with this specific plant above other tannic botanicals we use, with its ability to fight a lot of different bacterial organisms as well as viruses that other tannins and other plants just don't seem to fight, like its ability to fight malaria mentioned earlier. So sometimes the effects are a bit contradictory in that it may be a probiotic once consumed by a fish and in the gut of a fish. It may be that it helps their gut biome and helps them digest food. Yet, on the other hand, on the surface of a leaf that's just floating in your tank, it may be actually probiotic and helping other biomes of bacteria to grow and colonize. So where it may kill certain bacteria, it will encourage others. And how it selectively encourages what we consider to be the beneficial bacteria related to nitrogen cycles and carbon cycles is really amazing and almost head-scratchingly complex, in that it can both help and harm bacteria and fungi, and seemingly in a selective way that works out best for fish and shrimp. And this is, of course, because the fish and shrimp evolved alongside them, as well as the bacteria, fungi, and viruses, all to have a certain role within their ecosystem. So let's get back to the specifics of this plant and its place in the ecosystem to talk about why it does the things that it does. So getting back to the specifics of this marvelous plant, the leaves are large, 15 to 25 centimeters, that's 6 to 10 inches long, and 10 to 14 centimeters wide, or 4 to 5.5 inches across, in an ovoid spade shape. Their texture when still green is a glossy, dark, kind of waxy texture, and once the dry season starts, they start to lose that and they become more leathery and matte look in their finish. However, the dry season, when they are losing the moisture, is when trees begin to start shedding their leaves, and also when the colors begin to turn. So just like in North America or Europe, where deciduous and carnivorous trees have different methods of shedding and turning colors different times of the year, these are coniferous and deciduous trees from the tropics, which basically fall into palms and cactus type plants, and then into trees, shrubs, and bushes. And the deciduous type, like the CATAPPA leaf, is going to still lose its leaves, even though there isn't a cold season necessarily, but there is a dry versus wet season. And so it is the drier it gets, the more that it will lose those leaves, and then they will all fall eventually before returning when the rain returns. Now what's kind of cool is that they turn all sorts of different colors, from red to orange to crimson or even purple, as they turn this color and as the chlorophyll drains from the plant, which creates photosynthesis. These other colors are always there and present as compounds in the plant, but they drain away and are left in a sequential order as the plant matures. So the plant has all those color compounds, including the green and the chlorophyll, when it's lush and wet, but when it becomes dry, as it's on the tree longer, it has several different layers of those colors, ending in kind of a purplish color, and then finishing in kind of a bronzy hue when those compounds and the water are completely out of the leaf in any meaningful way. So that is when the leaves will then detach with even a slight gust of wind, or even just fall off on their own, and they'll fall to the ground in kind of an auburn or brown color that's familiar to a lot of us. Let me show you that color really quickly. So here's that color of a CATAPPA leaf that has naturally fallen and is then dried later and sold. Whereas if it is a fresh leaf on the tree, they'll dry it out and the chlorophyll will still decompose, but oftentimes you'll see a lighter colored leaf of a yellow nature, or even sometimes you'll actually see purple and dark red leaves, and that means they were about to fall off anyways. Well, all these colors are coming from pigments and compound chemicals that are in the plants. So things like volxanthin, lutein, and zeaxanthin, as well as anthocyanins, athaptascan, and a host of other chemicals like lycopene and carotenoids are all present in CATAPPA leaves, whereas some leaves in other trees only have one or two of these pigments. CATAPPA leaves kind of have a whole host of them. Back in there you can see a coconut tree palm frond, and you can see how it's kind of just white and doesn't have a lot of color, and that means that it's not going to have the benefits of the color enhancement to your shrimp and fish, because it is those same pigments and color compounds that cause your fish to look colorful and beautiful. So the other compound that they have is guanine and guarine, which are building blocks of life, and although many plants have these compounds, that is what causes the sparkle or the shimmer that looks almost like gasoline or a prism of light on fish scales. That silvery rainbow kind of combination that you see is actually little prisms, and those are needed by the fish in their diet, or they won't have as many, and they won't be able to show off for mates and so forth. So you can actually increase the color, and as many products advertise color enhancing traits and things, it's actually lycopene, which is also found in tomatoes and carrots and things, which has a host of other health benefits, but that is a pigment that is found, and that's what causes, for instance, the red in a lot of fish. Same with a lot of reptiles and birds as well. So in a very real way, if the leaf was on the tree and was picked, it will have all the different color compounds that the leaf could have, whereas if it made it to the end of the season, fell to the ground itself, it may have already had a deterioration in a few of the color compounds that you're seeking. Either way, it's a great way and a natural way that the fish are used to of acquiring these compounds through bioaccumulation and eating tiny creatures that eat the leaves and eat the compounds in the leaves and in the water that are put out. So it's a pretty interesting process when you start talking about why it is that tannins work the way they do. So let's talk about that a little bit. So, discussing the leaf from a more holistic point of view, we'll talk about the general benefits of the tannins, but more specifically cover the chemistry and research of how they work and why they evolved the way they did, and why the tannins and other chemicals in them have the impact they do on creatures that evolve with them or with plants similar to them. So, it's much more than just turning your water a yellow or reddish color like a tea. These compounds were in the water in many parts of the world, including most flooded jungle ecosystems, lakes, and rivers, and that is what your fish evolved to easily metabolize into useful pigments. So not all tannins the same, and more importantly, not all dried leaves are the same, obviously. So it may sound a bit dumb, but we can selectively decide when and where these leaves should be used. So when putting them into our tanks, you can put in a few and wait and see what happens. Test your water, test your pH, and see what happens. See if 1 leaf per 10 gallons is enough, and then add more if needed until you see the desired effects. So talking about desired effects, let's get this obvious stuff out of the way so you can get into the deep dive info. So in fact, nearly all aquarium related videos I've watched cover these next few issues regarding tannins to some degree, and they're based on research and empirical evidence which demonstrates some of the most known and impressive benefits of these leaves. First of all, being the color, the stain or taint that it adds to the water. So here's the basic info. The leaves create tannins to act as a bitter or repulsive tasting form of pest control. So after all, who wants to eat some bitter and buttery textured leaf that coats your mouth and throat with an oily and chemically astringent tasting chemical? I know I wouldn't, and bugs don't, so this has worked really well for plants. This is why tannins evolved. And over time, over 150 million years plus, they began to specialize the way they evolved. So they began to process into different other compounds and enzymes and complex compounds to specifically work with the ecosystem they were in. So if one animal becomes resistant or immune to the impact of the bitter taste, they can start adding a little bit of this chemical or a little bit of that chemical through evolution. And even though the plants aren't necessarily conscious of it, through this trial and error, they then can essentially change their arsenal up into something different and something that works better. And that's how we get all these variations of these chemicals. So we already know of over 8,000 different tannins in different plants. And chemically speaking, they are a phenol that is always water soluble and almost always acidic, with a tendency to form large molecular compounds and even to bond with metals, as I mentioned with the copper previously. So they have the ability to transform into polymers, meaning they are these long chains of molecules that are able to envelop and wrap other elements and chemicals and bond to them. So they can actually take the copper in the water, wrap around it as a polymer chain, bond with it, and then it's too big to do damage in the liver or kidney of a fish or shrimp, for instance, that may be sensitive to it. And then, even though I say it's large, we're talking about a microscopic scale, so it's not able to get in the cells of the fish, but it's able to still be floating in the water. And when you do your water changes, it simply goes out and down the drain with the water. So over the last 100 million years, plants have evolved to utilize their own biological waste from a primary purpose of growing and metabolism monitoring and metering. And they've created tannins, which have the secondary impact of that bitter taste. So essentially, they are a secondary use when we see them. They are not there simply to act as a deterrent for pests or bugs, but rather they're there so that the plant can metabolize and use energy properly, and then it just has the happy coincidence of keeping away bugs and insects and animals that might eat it. So as a secondary metabolite, it is simply a part of the plant's growths. And just like lactic acid is just another byproduct of human muscles working, tannins are in fact just a complex set of different acid chemicals and kind of a compound stew. And they happen to have antibacterial and other properties, including seemingly paradoxical probiotic and probacterial properties, as mentioned before. And other organisms co-evolved alongside them in ways to utilize these because they were present in the ecosystem. So the ability of tannins to form these long chains of phenols and to dissolve in water helps them to drop the pH of water as well. It's also evolved alongside things like bacteria that break down leaf debris, and every year that bacteria depends on those leaves as a host. And things like our nitrogen eating bacteria, or rather ammonia and nitrite eating bacteria that put out nitrogen that plants can use, all find the plants themselves and the leaves a great home. So in fact, after the chlorophyll and water are gone from the leaf, it is usually 40 to 70% tannins, and the remainder of the leaf is simply just the skeleton, the veins, and the stem of the plant, made of more important macro elements such as carbon, nitrogen, hydrogen, phosphates, potassium, manganese, magnesium, zinc, and iron, and their molecular constituents that are created from those all interchangeably and built in different ways, like sugars and starches and proteins, all of which are introduced into your aquarium and its ecosystem when you add any botanical matter such as almond leaves or wood. These things are still broken down by the fungi or the archaea or bacteria in your aquarium, and then they are turned into mulm, or basically debris at the bottom of the aquarium that then is rich as a fertilizer for your plants. But while that's going on, they also leach a whole great deal of their tannins and active ingredients, which are anything but the skeleton of the plant, essentially, and they do a host of things that they've evolved in tandem with plants, fish, and other creatures happily to do. And we're still unraveling some of the incredible things that they do. So one of the most incredible things that they do is that they act like a foundation for biofilms and colonies of microscopic life. Organisms from tiny infusoria that serve as food from our newborn fish, to jungle gym-like matrices of the leaf pieces which are starting to fall apart, but still holding on to important elements and compounds that things like shrimp or even tinier creatures can then utilize. So it's not necessarily the leaf itself that the shrimp or your fish are eating, but actually one or two steps up the trophic pyramid or food web that they're using it. So this also serves as a direct food as well, though. Because these specific leaves, CATAPPA leaves, are so nutritious, they are used by the shrimp as a primary food source if the other sources such as aufouks and algae are not available. So more importantly, these leaves act like little storage containers of vitamins and minerals, and they serve as a home for all sorts of beneficial microorganisms and little creatures in our aquarium. So these surfaces develop into diverse micro-ecosystems that are basically protein layers and biofilms that we call aufouks. And aufouks is a German word. I have a whole video on it. But basically it's a community of different organisms that come together to form a matrix or a thin layer of life. And that can be archaea, algae, bacteria, fungi, and even little animals like microcrustaceans, ostracods, nematodes, single-cell organisms, paramecium, and even up to the size of things like worms and shrimp that feed on them. So together they are the foundation of every aquatic food web. And you can see back in this tank, as they get older, the plants themselves are getting broken down by the bacteria and things, and the shrimp are then eating the other things growing on it. Well, one of the most important concepts to understand about this whole thing is the idea of bioaccumulation. And that is that the shrimp and fish prefer to eat the fungi or bacteria on these surfaces a lot of times, rather than the leaf itself. And the reason behind that is what makes tannins so amazing and useful. So the key concept to understand here of bioaccumulation is really interesting, and it is where the leaves themselves, or any creature that can create energy from the environment, such as sunlight, or from a rock, or from another chemical such as sulfur in extreme cases, those eutrophic creatures are able to, eutrophic and heterotrophic creatures, the difference is that fish and shrimp generally eat the things like plants, like bacteria, like fungi, that make energy and food out of substances, and they have to go farther up on the food pyramid and eat the things that have already collected that nutritional profile that they are going to then eat themselves. So, for instance, your shrimp may eat half a gram of leaves to receive the vitamins and minerals it needs, when instead it could eat 1/20th of a gram of the same amount of weight of the biofilms living on the leaves, and it will contain the same amount of vitamins and nutrients as that original half a gram of leaf material had. So as we move up the food web, each organism does this same little trick. So if algae and the biofilms take that half a gram of daily nutrients and condense it into 1/20th the size of the package of the leaf material, the shrimp, snails, and worms, etc., they then take those small organisms like nematodes or single-cell organisms or that biofilm, and they're able to pack it into even more densely packed nutrients. So within the shrimp, it becomes like another layer, or another, usually exponentially more condensed amount of those nutrients. So by the time you have shrimp eating the biofilm and the other little micro creatures and algae that are growing there, they're getting 20 or 40 or even 200 times the energy that the leaf would have had in the same amount of weight. And it's because all these creatures moving up the food web are able to utilize the work that the creatures before them did. So fish then eat, for instance, shrimp, and they get all that energy, and rather than wasting their time eating the leaves, it's much, much easier just to hunt and eat shrimp and get all those benefits. And over time, those microorganisms and different compounds and things, they build up, and they can actually store things like calories, nutrients, and vitamins. And it's those first few days that a fish is free swimming that they rely on these active little ecosystems of growth on surfaces. And leaves and botanicals are great for that. So it's a beautiful, elegant little system of bioaccumulation. And by the time the baby fish are eating the second or third level of small organisms that were eating the tannins or eating the sulfur that came out of the leaves, and then that in turn gets eaten by another larger bacteria, which gets eaten by a single cell organism, which gets eaten by something else. They're taking the most important parts of that, getting rid of the waste parts, and saving it as a little packet. And that is how carnivores and creatures higher up on the food pyramid are able to utilize all these benefits. And even without having a fish that is strictly eating a leaf, so even though your betta is not eating the leaf, it is both absorbing the tannins and compounds that are in the water that are put out by leaves, and it is getting that nutritional benefit from eating the microorganisms that have bioaccumulated it, which I think is super cool. So many fish evolved to live in rivers and lakes that are absolutely filled with leaves, and thus by default they also evolved to swim and thrive in water impacted by tannins. And tannins just happen to acidify the water, and that is why a lot of fish from flooded forest regions like the Amazon or the Congo or Southeast Asia happen to love and use tannins so efficiently. Many fish like tetras, rasboras, bettas, gouramis, and shrimp rely on some level of tannins in their diet, or at least in their water. And it is these that mimic the nutrient profile of their natural ecosystem when we put CATAPPA leaves into aquariums. So as I said in the beginning, they're a good general model for their ecosystem, even if they aren't the exact thing that they have in their ecosystem. So some fish need really acidic waters and very little TDS in order to spawn, while other fish might need the other end of the spectrum. So like live bears or Lake Tanganyikans, fish like guppies or swordtails, for instance, wherever they are in there, they actually want alkaline water. But CATAPPA leaves and tannins are also useful in alkaline water because of all those nutritional and chemical effects they have, like the antioxidant effects, like the probiotic effects. It's just you need to be careful when using them in water if you intend it to be alkaline, because they will make the water more acidic over time. So you can counter that by having a buffer such as carbon and calcium in the form of crushed coral or shells or limestone in your aquarium. So all of this is important to understand, because one leaf which may be harmless and actually beneficial to, say, an angelfish might be harmful to a guppy if you put it in neutral water, because it would drop the acidity. It would drop the, or it would rise, it would drop the pH and raise the acidity. Sorry, I always say that backwards. So in tropical and ornamental fish, far more live in those flooded forest parts of the world and rivers and creeks and lakes that have a lot of leaves than fish that don't. And so a lot of them like mildly acidic waters. So it's a pretty safe bet that CATAPPA leaves are going to be appreciated by your fish, at least in some amount. The dose is what makes the poison, as they always say, so do your research first. So as a general rule, the fish that come from these acidic waters are going to benefit a little bit more from tannins, just because they have grown in water filled with those leaves as well as the same chemicals, and they've evolved ways to use them in effective and innovative ways for much longer than some of the fish that live in alkaline conditions. That's not always the case, but it tends to be true. So using things like leaves, bark, or wood to change the acidity in your tank is often very helpful for fish that are in the ornamental hobby. And like I said before, it's a minority of fish that actually want that harder water or higher total dissolved solids and more of alkaline conditions than the slightly acidic conditions. So tannins serve as a way to balance that same chemistry, because most leaves deteriorate into organic acids on their own. So the skeletal level of those leaves actually develops into nitric acid and carbonic acid as well as humic acid, whereas the tannins and other compounds within the leaves turn into tannic acid, carbonic acid, gallic acid, pyrogallic acid, and various other trace acids that you'll find in nature. So every leaf, every different plant is going to be different, but it's going to help mimic the waters that our fish most likely grew up in and evolved in. So beyond maintaining the fish's immune system, their gut biome, creating a rich food source that is hyperloaded at each level of the trophic pyramid, including color-enhancing compounds, and also wrapping around harmful elements like heavy metals, it also stabilizes their water chemistry if that wasn't enough. Beyond this, if that wasn't enough for you of reasons to use CATAPPA leaves and botanicals in your tank, they also have a lot of extra benefits to each individual plant species, and that is what is going to be unique about today's video, truly. And that's everything from that reducing inflammation, possible cancer prevention or cancer fighting properties, anti-aging effects, antioxidant effects, liver and kidney support and health encouraging traits, as well as countless other yet to be discovered attributes. But as I said, take everything with a grain of salt. You know, some people promise the world and say that it will fix everything for you, whereas the truth is probably somewhere in the middle to not there at all. So almond leaves and many other larger sized leaves also provide a habitat for fish themselves, which is also kind of common sense. But the very shape and structure of these leaves is helpful for many young shrimp and fish that rely on plants and leaf litter. So just like in this tank, we see a little baby leaf on there, a little baby shrimp on the leaf. He's hiding from any potential predators out in the tank. And while doing so, he also has his food source there and his nutrient source. So it's like he's got a house, vitamins, and a hospital or doctor's office all in one place that then deteriorates and turns into nutrients for plants and the ecosystem at large. It's like win, 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 win. So after all, the jungle is rarely made up of only one tree, and our aquatic pets often rely on a mixture of these chemicals naturally to have a balanced health and well-being. One of the biggest benefits to almond leaves is that they contain the same nutrients as those other plants, as I've said several times now. But even if we don't know what exact environments our fish are coming from and what the plants and their chemicals are giving them, we can go off the knowledge of all the research that's been done on CATAPPA leaves, as well as other leaves like oak leaves, guava leaves, maple leaves, cinnamon leaves. They've all been studied very heavily by pharmaceutical companies, and so we can recreate a fairly safe and predictable approximation of the properties that occur in the water columns these fish live in the wild. So lastly, I wanted to talk about just a little roundup of the most common questions I get regarding CATAPPA leaves. And these are questions that a lot of you guys asked during live streams, but also questions that were the most common on Google, and just questions that I've received when I worked in fish stores all the time. So let's finish off the video on this note. So the most common question I usually get is how much of the leaf or bark or whatever piece of the plant or botanical being talked about should I use in my aquarium of X amount size or X amount of gallons or liters? And the answer to that I kind of answered already, and that is you should ideally take some water from your next water change, put it in a bucket, and with the elements of things like trace amounts of nitrates, nitrites, and all the different compounds that are also floating around your tank, you can then have an approximation of what that leaf or the bark or seeds or berries or nuts, what they would do to your aquarium. So try adding in a 5-gallon bucket, take maybe 2.5 gallons or even the whole 5 gallons, get some aquarium water in your next water change, put it in there, and take water parameter measurements of the pH and of the total dissolved solids and the KH, the GH, and just note the color, maybe even ammonia or nitrites and nitrates, and just double check, put whatever it is you got, and if you got it from a good source, online or in a local fish store or from a provider that sells botanicals for this specific use, you should feel safe in knowing that once you kind of figure out your basic dosing, you'll be good to go. But I mean, I'd recommend starting with a leaf or half a leaf. You can eyeball whatever seems reasonable, and you're doing it in your bucket, and then you can put it in a glass of water or something like that. That's a silly statement. You can put it in a glass, like a water glass, and then look at the fish tank water and see what color it changed, and see how strong it was. But more importantly, what's going to matter to the health and safety of your fish is how much did the pH, or the total dissolved solids, the KH and GH, how much did that stuff change? So that's why you need to know your baseline before you put the botanicals in and after. But the answer is, you know, do a test. You can also just use tap water. If you want to just start with tap water, or if you use RO DI water, use RO DI water in the bucket. Put a leaf or half a leaf in, let it sit 2 or 3 days, if not a week, and see what happens. That's always the safest way to do it. So the next question that I get all the time is, should I boil my leaves? Should I clean my leaves? Should I cook them? And the answer to that is, well, if you're getting them from a trusted source, then you don't really need to do any of that. And in fact, a lot of the compounds and chemicals that are in CATAPPA leaves break down when they are heated, or if they are frozen. A lot of organic compounds, when frozen, if they're in the cell of a creature or of a plant, those cell walls in a plant, or cell membranes in an organism, they rupture due to ice crystals. And so if the leaves were frozen or kept in a freezer, they may have their ability to still provide the base elements and some of the nutrients that are in there, but any of the active enzymes, things that maybe help bacteria grow, or help them digest things, or fight other complex ailments, or maybe inflammation and things like that, it's likely that a lot of those compounds and chemicals are going to be reduced, if not eliminated, by either freezing or boiling. Now, boiling is a way where you can actually take the color out of the leaves somewhat. So you will boil the leaves for 20 to 30 minutes, just gently stirring them with a spoon. And if you don't want the potential organic compounds of any leaf in general, I'm not just talking about CATAPPA leaves, but say you find a leaf and you're not sure about what it does, maybe you want to boil it just to make sure it's not going to have an impact on your tank, other than being a structure for beneficial bacteria and a structure for little fish fry and shrimp to hang out on, and to decompose into a nice fertilizer or mulch for the aquarium. So that's one way to do it. Now, another question I get is, you know, does boiling it ruin it? And I feel like I just answered that. But by ruin it, I'm not being super clear, and usually people ask in that exact way, and that's why I said it, which is, does boiling the water cause the impact or the desired effects of CATAPPA leaves or botanicals? Does it reduce their impact? As I just said, yes. But it also sometimes will help get the acids and some of the pigments and things out of the plant and into a liquid solution. However, at 80 degrees Celsius, so just below boiling, almost 100% of the tannins are leached, and then all of the biological compounds are still going to be intact, like the enzymes and things like that that are more delicate and could be cooked, which would rearrange their molecular structure. Proteins and fats and things like that, you can preserve those by just heating it to 60 or 70 degrees Celsius. Keep it under that 80 degrees Celsius, or for those of us using Fahrenheit, keep it at like 120 or 140 max Fahrenheit. And that will allow them to hold on to most of their shape, as long as you do it for less than 20 minutes. Now, there are potential pathogens and bugs and bacteria and fungi that could come in on a leaf, worms as well. And so it's important to either trust your source and know that they dried them thoroughly, or that they treated them with steam at some point, or there's a number of ways that they can be treated, and you can be reasonably sure that they're not going to be a detriment to your aquarium. But one is, yeah, trust your source, know where they're coming from, and that's where the idea of them being $1 a leaf is a ripoff is not necessarily true. I mean, for your average person who doesn't want to do all the research and studying and then looking for whatever local plants are around and selecting the correct ones that don't have any other secondary fungi or mold or algae or lichen or who knows what on them, the CATAPPA leaves are a good way to go, because they are mass produced for the aquarium hobby, and they're pretty consistent as well in their issues. Sometimes you'll see a little bit of white or black mold on them, and when you do see that, I would either boil it or cut it off and just not use that section of the leaf. That's my best advice, as well as where to store it. If it's very dry air already and the leaves are completely dry, you can put them in a plastic bag or a glass jar. But if they're still springy to the touch, they don't crack like a cracker when you try to bend them, you want to keep them there in like a paper bag or something that has some breathability for the humidity involved. Otherwise, again, you'll get the mold issues and mildew and things like that can occur, because the leaves are pretty nutritious. Go figure. So one of the last things that people ask frequently, almost every time I talk about Blackwater tanks, is, can I have the look of Blackwater without the impacts? And I think I just explained to you guys that you can get the nutrients, the metal elements, anything that's not an active organic compound or lipid or protein, as long as you don't need that intact, or you're not seeking some property of a specific botanical or the CATAPPA leaf for that reason. For instance, helping the slime coat of a betta, or helping the saliva for bettas and gouramis to make nests at the surface, the fact that they can utilize elements of CATAPPA leaves for that, then you don't want to just put the discolored water you boiled the plants in. In that case, you want to either simmer or below simmer, you know, a good 20 degrees below boiling Celsius, if not 40 degrees Fahrenheit below boiling, so you don't cook all those compounds. And then you can add that water and the leaves if you want, if you want the color. But if you don't want the leaves themselves, there'll still be a lot of those chemicals, and all of the tannins should be leached into the water at that point. It's just, remember, if you cook it, you rearrange the compounds. You also kill any pathogens that are on there, but you also break down any of those really cool, delicate, and exotic compounds that people work very hard to find, or that a lot of medications and oils and extracts are actually, or tinctures are made out of specifically to utilize. So the last thing that I wanted to talk about was the question of, can I lower my pH without changing the color of my water? And the answer to this is yes, but don't use alder leaves, really. You can make the leaves less likely to change your, don't use, I said alder, but I mean CATAPPA or alder or maple or anything. you can use the leaves themselves if you like the look of them after they've been boiled. If you're worried about them changing the pH, after you boil them, they're a lot less likely to change the pH substantially because you've boiled and then poured off the tannins and a lot of the other compounds. So you're left with that skeletal frame of the veins and the leaf tissue. And then that pot has all the water and the chemicals which have been cooked and rearranged. But if you put the botanicals in your tank, then ta-da, you've got botanicals that you can look at if you want lotus pods or this or that in there, leaves, but your water's already acidic enough, then you can do that. If you have the opposite problem, which was how I started the question of how can I change the acidity without making my water look all yellow, because some people just don't like the look of that yellow hue, the way you can deal with that is actually adding nitric or humic acid, but that becomes a lot more tricky. You have to have a dosing regimen, and while people do it, it's the margin for error and the ease of causing a fatal problem to your fish or shrimp especially goes up immensely with that. Now, for people, if you're drinking tea and the tannins in it, for instance, CATAPPA leaf tea that's used in a lot of Asian cultures for upset stomachs and things like dysentery or when you've got the runs, as I'll try to say politely, what it can do, what the tannins in the CATAPPA leaf can do is sometimes the tannins that are helping your stomach, there's other ones that aren't, and you need to kind of neutralize that acidity that is also causing your stomach acid to be upset. So in a lot of cultures, they'll put a squeeze of either some sort of vitamin C rich juice into the drink, which will still have some acidity, but apparently vitamin C bonds to a lot of the tannins and makes it so they're these big clumps of molecules that don't get absorbed as much. And if you add enough lemon juice, you'll also break down the tannins, but that would raise the acidity. So if you're having heartburn or something that's the problem, you don't want to do that. In which case, if you're having too much acidity already in your tea, then a lot of cultures add milk. So that was just the last little tidbit. I don't intend or hope that most of you guys don't intend to be drinking any tea made from aquarium grade CATAPPA leaves, but you know, it's just something I wanted to mention, and also wanted to mention that you can use your local plants and save money, of course, but they're all going to have different compounds, so you really need to do your research, and you need to look up what tannins are in those plants, what chemicals or phenols are in those plants as a whole, and you need to go slowly testing, and then doing research on what that means for your fish. So that concludes everything today, and I'm sorry that I started tripping over my words at the end here, but thank you so much for joining me. Congratulations, you guys made it to the end of the video, so thank you so much for joining me on this journey through CATAPPA land in a very non-TikTok way, long-form content. You are the hardcore of the hardcore fish nerds, and if you want to let folks know and let me know that you enjoyed this content, made it to the end, simply leave the comment and the word endurance somewhere in your comment, even just on its own if you want, in the reply as a way to kind of wink and a nod, let me know that you guys enjoyed it, watch the whole thing, and you know, sometimes I draw prize winners and things later on from it. If, say I had a giant bag of CATAPPA leaves coming or something along those lines. Alright, thanks again, and have a wonderful week of fish keeping, and I will talk to you guys next time. Thank you. Bye.